Welcome to Geometry, Section 1.4, Angles and Their Measures. Our goal is to find and compare the measures of angles. The essential understanding here is that you can use number operations to find and compare the measures of angles. An angle consists of two rays that have the same initial point. In this angle here, we have two rays, ray 1, which is ray BA. Remember, you name a ray with a little small ray above it in its initial point first. And then we have ray 2, ray BC. Both of these rays have the same initial point of B. B is also the vertex of this angle. We're going to write three names for the angle, and then we're going to name the vertex and its sides. An angle that stands alone can be named three ways. We can name it just by its vertex, angle B. The symbol for angle is just a small angle that comes in front of the name. Then we could name this angle, angle A, B, C, with the vertex in the center. Or we could name this angle, angle C, B, A. When you name an angle with three letters, it's essential to have the vertex in the center. The vertex is just a point, so we wouldn't name it with a symbol. We would just call it B, and that would represent a point. And its sides are ray BA and ray BC. All angles have an interior and an exterior. In this first picture, point P is on the interior of this angle. In the second picture, point P is in the exterior of this angle. Interior means inside, exterior is on the outside. Take a look at this picture. We're going to name the angles in this figure. Let's start with this largest angle. We can name this angle, angle IVF, or we could call it angle FVI. Let's find another angle that begins here at I. We have this angle, IVG. So this second angle, we could name it angle IVG, or you could name it angle GVI. Can you find another angle? How about this one that also begins here at I? Angle IVH. Did you see that one? Angle IVH, or you could name it the other way, angle HVI. Do you notice something that these all have in common? Can you spot another angle? Not one that starts with that ray VI, but let's start with the next ray, VH. How about this one? HVF, or you could call it FVH. So the fourth angle that we see in this picture is angle HVF, or you could call it angle FVH. Are you noticing a pattern here? Can you spot one more angle? How about this one? Angle HVG, or you could call it angle GVH. Because all of these angles have a common vertex of V, you can't name any one of them V because they are all V. So if you said, hey, look at angle V, I wouldn't know which one you were talking about. In this situation, when angles share the same vertex, you have to name the vertex using three letters. You could not name any one of these angle V because they are all angle V and it's not specific enough. So you would have to name any of the angles that you're speaking about in this picture using 3 letters. So moving on, suppose an angle measures 60 degrees and that there is a point K in the interior of the angle such that the measure of angle GHK is 25 degrees. Let's find the measure of angle KHI. Well, in order to do this problem, let's draw an angle that approximately looks like it's 60 degrees. So we'll say this one. And I know that K is in the interior of this angle. So I'm going to put it on the inside. That means that these other letters are on the outside. Which one would be the vertex? Well, H is in the middle, so H would be our vertex. So this would be angle GHI. I know that the measure of angle GHI, the whole thing, is 60 degrees. I have this point K inside on the interior such that I have this angle GHK. If I know that this angle is 25 degrees, can I find the other piece? Well, because angle GHK is inside angle GHI, then I know that if I have the whole and take away the part, I could find the other part. Because these two smaller angles, angle GHK plus the measure of angle KHI will equal the whole, the measure of angle GHI. So 25 degrees plus, I don't know what KHI is, will equal the whole thing, 60 degrees. Using the subtraction property of equality, I can subtract to find that the measure of angle KHI is 35 degrees. Two angles are adjacent angles if they share a common vertex and a common side, but they have no common interior points. What is and isn't an adjacent angle? Well, this is an example of a pair of adjacent angles. These share a common vertex and a common side. It's kind of like your next door neighbor. Your neighbor next door to you is adjacent to you. You share a property line. And sure, you have neighbors across the street diagonally, but they're not your next door neighbor. They're not adjacent. So these angles here, these are adjacent because they share a vertex and a side. This is an example of not adjacent angles. This angle here, A, and this angle, B, they're not adjacent angles because in between them is this space. They live in the same neighborhood, but they don't share a property line, so they're not adjacent. These angles here share a property line, but they don't share a vertex. So these are also not adjacent angles. They do not share a vertex, so they are non-adjacent. And this is another example of not adjacent angles. These angles, angle B, which is this large angle, and angle A, which is this smaller angle, they do share a common vertex, but they overlap, and adjacent angles don't overlap. They cannot have any common interior points. They share a side and a vertex, and that's all. Angles that have the same measure are called congruent angles. This is just like when we had congruent segments. When we had congruent segments, we use little tick marks or dashes to represent that they were congruent. In angles, we use this little arc symbol. So if the measure of angle A equals the measure of angle B, then angle A is congruent to angle B. And we use the same symbol for congruent that we did when we marked congruent segments. This is another example of congruent angles. We have here angle ABC is 50 degrees and angle DEF is 50 degrees. So because their angles are equal measure, they are congruent. Notice that these have two little arcs. One arc matches to one arc, two matches to two. So because they both have two, that represents that they are congruent. And you would write angle ABC is congruent to angle DEF. That would be a congruent statement, a statement of congruence. Here we have another postulate, postulate 4, the angle addition postulate. If P is in the interior of angle RST, then the measure of angle RST is the sum of the measures of angle RSP and angle PST. So, in symbols, if P is in the interior of angle RST, then this is the angle addition postulate in symbols. The measure of angle RSP plus the measure of angle PST is equal to the measure of angle RST. Let's use the angle addition postulate. If we're given here that the measure of angle ABC, so that's this larger angle, is equal to 89 degrees, we want to find the measures of the other two angles. Well, the angle addition postulate tells us that the measure of angle ABT plus the measure of angle TBC is equal to the measure of angle ABC. So what we're going to do now is we're going to substitute in the values for these angles. If we know that the measure of angle ABT is equal to 12x minus 7, we would say 12x minus 7 plus the measure of angle TBC is represented by this expression, 5x plus 28, is equal to, we were given that measure of angle ABC was 89 degrees. So using substitution, we just placed in all of these values. Now we're going to combine like terms. We want to simplify on the left side of the equation. 12x and 5x will give us 17x. Negative 7 and 28 is plus 21 is equal to 89. To get to our next step, we're going to use the subtraction property of equality to say that 17x is equal to 89 minus 21 is going to give us 68. In our last step to solve for the variable, we're going to use the division property of equality to solve that x is 4. Well, we found the value of x, but that wasn't our mission. Our mission was to find the measures of the other two angles. That's what we were trying to do. Find the measures of the other two angles. So, we want to substitute in the value of x to find what they would be. If we know that angle ABT is 12x minus 7, well, the measure of angle ABT is equal to 12 times, instead of x, we're going to substitute in the value of 4, minus 7. So we know that the measure of angle ABT is 48 minus 7 for 41 degrees. Now here we have a choice. We could say, well, we knew the whole thing was 89 and we could take away 41 to find what the measure of angle TBC is, or we could just do the same thing and substitute in the values. The measure of angle TBC is equal to 5 times 4 plus 28. So we know that this is 48 degrees. To check it, if we add the two together, 41 and 48, we know we get the total sum of the measure of angle ABC. ABT, we said, is 41 degrees, plus TBC, which is 48 degrees, equals the total 89 degrees. This is using the angle addition postulate. The last thing we're going to discuss in this lesson is classifying angles. We learned how to name angles. When you name an angle, you name it with its letters. Classifying angles is saying what it is by its size. You've learned before these names, and so you probably remember them. Acute angles are angles that are less than 90. So greater than 0, less than 90. You can remember it because they're cute. They're small. Right angles are exactly 90 degrees. They equal 90 degrees and are generally signified with that square that makes the 90-degree angle. It shows you that it's a perfect 90-degree angle. Finally, the last two, obtuse angles. An obtuse angle is an angle that is greater than 90 degrees and less than 180 degrees. And then the straight angle. A straight angle is made by two opposite rays that form a straight line. And it measures exactly 180 degrees. Every straight line is 180 degrees. This concludes lesson 1.4. What I'd like you to think about is this. How many sides can two congruent angles share? And why do you think that? We'll discuss it in our next class. Remember that if you have any questions, comments, or concerns, you can always email me. And please, write down any questions that you may have on your notes if you don't get the opportunity to email. And we'll discuss it as soon as you get in your next class. See you soon. Bye.